Here we have a 5-inch cone that's created by rotating the line y equals 0.3x around the x-axis, and we're going to find the volume of the cone. All right, now you may have seen cones in previous classes that look like this, and the idea is that to get this cone here, we start with something looking like this, and we draw the y-axis there. We draw the x-axis straight down the center of the cone. So just straight down the center of that cone. It's the x-axis. And then that's how we end up with this thing here. Now let's think conceptually really quickly about how we get this volume. How we get this cone, how we get this three-dimensional object from a two-dimensional area. So let's start with the two-dimensional area. I'll draw it here. And so I'm going to draw basically the line y equals 0.3x. So there's my line y equals 0.3x. And going out to x equals 5, the area under y equals 0.3x, right? That would be all of this blue area here. And the way that we get the cone is we rotate this area 360 degrees, one full rotation around the x-axis. And so that blue area is exactly this blue area in there. Just think of that as a two-dimensional area there, and we rotate it around 360 degrees, we get the cone. So now let's talk about finding the volume. So here I've drawn a cross section, a thin cross section of width dx. And then let me give that a little more volume, look more voluminous. There we go. Now, if we were to take this off, right, this would actually be a circular disc. Where the width of this circular disc is the dx. And I want to stress that the top of this disc is in fact a circle, because we're rotating these things around the x-axis, we're creating circles. At each x along here, at each x along from 0 to 5, we have a different circular cross section. The circles get bigger as we move from x equals 0 to x equals 5. So wherever we're at, whatever x we're at, there's some radius here, right? There's some radius. And the volume of a disk, the volume of this arbitrary disk, is the area of the top of the disk times the height. The area of the top it's a circle, so we have pi r squared times dx being the height. So we have pi something squared, the radius, squared times dx. Now this radius here, that's exactly, let's say that's at a particular x there, that radius is exactly 0.3x, right? Because this is the line y equals 0.3x. So we have 0.3x there. which is, okay, let's see, pi times 0.09 x squared dx. So if we're going to add up all of those disks all the way along for all the x's, the volume of the cone is the integral, the sum from 0 to 5, adding up all of those disks, pi times 0.3x squared dx. Remember, this is the area of the top of the disk. Top. And this is the width of the disk. Arbitrarily small disk. Arbitrarily small width. Now, one nice thing to do, remember these are constants here. Let's just pop those out to the front. So we have 0.09 pi, the integral from 0 to 5 x squared dx. We know how to do that. And our final answer is 11.78. Now we're dealing in inches. So we're going to, our units will be inches cubed.